Hello, everybody. Thank you for joining us, and welcome to Cloud Innovators Live. I'm Dan Dobrin, architect at Google Cloud, currently part of the North American technology team. Where I'm focusing on enterprise app modernization. Our focus today will be on building modern applications with Google Cloud, and we want to focus on some interesting yet different concepts with aspects such as shifting left tasks when building modern apps as a recurrent theme. Before we start, just a small note. Feel free to ask any questions throughout today's session using the Ask a Question or chat features, and we'll answer them as we go along. So, without further ado, let's get into it. Over the last several years, primarily the last 18 to 24 months, I talked to multiple teams in different geographies around new aspects as they were moving either existing workloads into the cloud or building new ones. And I wanted to understand what are development teams asking for. So developers on the design side want to build new applications. They want to modernize applications, but build them with new capabilities. For example, scale to zero or have fast starts with a lower resource consumption. On the development side, a big focus is on improving the developer experience. Teams are interested in improving the code quality and with a laser focus on building production ready applications using best practices and reusing blueprints and reference architectures. Now, on the build side, teams want to look into streamlined CI/CD pipelines. And as they test, they're focusing on the 12 factors or 15 factors, how we call them nowadays, on development production parity. And they want to test their applications with true cloud technologies. On the run side, developers want to abstract away the infrastructure management for a simple developer user experience, but they're focusing from the beginning on improving the cloud economics of their applications. For example, if they build Java applications, they're looking into building native images. On the integration side, flexible app integration is a major concern. While on the security side and maintainability, the emphasis is now on building better secure applications today, but securing also the supply chain. And last but not least, day two is as important as day one because of dependency management and because of the ever evolving nature of building applications. So, how should we look into building these 7 steps, which teams are interested in? If we would map them into how Google Cloud would allow us to build them, we want to before we do that, let's step a little bit back. My findings are quite similar to an IDC developer report. That's why I'd like to quote that, published at the end of last year, which was highlighting the fact that developers are actually spending 16% only of their time in building applications. And a lot of time is spent in testing and addressing the discrepancies between testing in their environments versus testing in cloud environments. A lot of time is spent on onboarding and the developer experience, and a third of their time is spent on automation. Now, teams would like to abstract away as much as possible some of them, shift some of these tasks left, and focus on bringing business value to their organization. Therefore, they want to focus more on development. So, if we think in terms of outcomes with Google Cloud software tooling, we have a clear focus on increasing developer productivity, for example, easy onboarding, reducing operating costs and scale. For example, we can use build packs versus Docker files, improve agility and reduce time to market. We want to deliver true business value, the ability to prototype rapidly, trial new products and services, and pivot according to market feedback. And the last thing, enhance innovation. So how should we start? Well, All these steps, in order to address them and improve all the aspects we highlighted, we want to start from the aspect of segregation of responsibilities and separate the personas. Software and developer architect and platform architects want to build templates and accelerators. They would help with either development teams of building applications based on best practices and using patterns and leveraging and improving consistency across an organization. On the other hand, platform oriented architects want to bring consistency on the build and deployment side. Developers want to use the template and focus on building business logic, while operators want to use the build and deployment artifacts generated upfront and have an improved CI/CD process. So this separation of personas would allow teams to work in parallel and bring consistency to their application development. Now, when we talk about separating personas and their responsibilities, we do that with some goals in mind. So our goals are building applications with production readiness in mind from the beginning, based on best practices. We want to generate declarative deployment artifacts. We want to adopt in the cloud an API first approach and leverage where we can contract as code. We want to shift left a number of aspects, and that will come as a recurrent stream through today's session. Testing, integration, security, and optimization. We want to introduce modern container standards, eliminate app build inconsistencies, and finally reduce the overlap and friction between development and operation teams. Now, let's try and map these steps one by one. Architects would build accelerators. These accelerators are artifacts which could be broken down into three areas: the development side, the environment side, and the infrastructure side. For whereas developers, and they could be provisioned in GitHub or GitLab, any source code repository. Now, developers, which are the focus of our session, want to take these artifacts and start building their applications. One of the things they're interested in is improving the inner loop of development, where Scaffold would come into play and help us out. Now, we can generate all these artifacts, and that's how we want to look at things. When a developer builds an application, a developer wants to test the application. So how would they test? They had always the challenge of testing with true cloud technologies. Unit tests with an in-memory database versus running a test in a cloud environment would yield discrepancies. There are differences in dialect between the different databases. So why not uh, test with containerized databases? To this end, Google provides a number of emulators for our major services: Spanner, Bigtable, PubSub, Firestore, Datastore. And for other open source databases, Postgres, for example, there are open source containers, and these containers would then allow us to test with the Postgres, the same Postgres which is supported in Cloud SQL in the Google Cloud. So we would be testing as developers with containers. Now, testing is also a focus of integration. So in integration testing, we want to run our integration tests as part of a build pipeline. So in here, Cloud Build allows us to run integration tests in a similar manner. This would allow us to set up pipelines for our applications and eliminate the discrepancies of the data, of having conflicts of data or or provisioning these environments. Now, as we build our applications, we also want to have a simple, clear, declarative pipeline where, as we want to build our application, and we want to be able to build the images, provision containers into artifact registry, and as we provision them to artifact registry, we want to scan them early in the process. As we build, we have the choices with Cloud Deploy to deploy into either GKE or in a serverless environment, for example, such as Cloud Run. Any production application, whether we would run it in any of the compute environments, would require to be customized for that particular environment. And we would want to have the ability to provision these applications with configurations specifically for that environment. For example, as a developer, I would never know what production environment configuration would be like, because I cannot have access to usernames and passwords, for example. But as a developer, I would like to do that. What is the recurrent theme through all these builds? Very simply put, declarative manifests. In here, we put them as YAML files. We can govern them, we can maintain them, we can use them in a consistent way. But we can also start by generating them based on accelerators and templates, which our architects would allow us would provision for us and make available to us. Now, can we refine these solutions? Let's think about this. How easy is it for us to refine these solutions? Because we have started shifting left, testing. We have started shifting left. We can build an image easily, get it scanned, and as it's scanned, we can eliminate easily before it gets into the entire CI/CD process. We can eliminate quickly any kind of vulnerabilities or understand why they occur and address them. So we can refine the solution with an example if we use cloud native build packs. So the cloud native build packs are leveraged by Cloud Build. Very simple, and we're going to look into an example, and it precludes us from the need to build Docker files anymore. Building Docker files was for some time a major point of friction between development and operation teams. Why is that? Because building good, a simple Docker file, not that difficult. Building good one and maintaining them is not an easy task. And building them at the level of an organization, which is building tens or hundreds of microservices, that becomes a task in itself. So what outcomes do we have here? One, yes, we eliminate the friction between development and operations team. But we also have an improved maintainability and security, because we can respond quickly to CVs. If we look into the technical news, weekly we would read about one or the other, either breach or security violations in the supply chain. We have now the ability to build with build packs, and as a build pack can change, Cloud Build can help us rebuild all our images. Now, can we simplify this even further? So Cloud Run allows us to, for example, we can build with Cloud Build and deploy to Cloud Run in one single operation from source to build packs. So source to running workloads in a simple, straightforward process without the need to use Docker files, and deploy directly from source code leveraging Cloud Build behind the scenes. So for us, as if we put our developers hat on, there are a number of things which we can help, because every process, every production ready application revolves the three personas: architects to bring us blueprints and consistency, developers to build applications independently of friction with other teams and allowing them to focus on where they're good at, and operators who want to have consistency in their builds, but without putting any burden on developers and without taking a significant amount of their time. Now, let's see all of these in action. So we started talking about the personas and the app acceleration. So let's think, how can we do that? Solution architecture within Google Cloud. And our technology teams are looking to build a software delivery platform. And probably this is the first time you would see that. As an app acceleration blueprint, organizations can build different app accelerators, but the the important thing is to build a platform which teams can easily expand and on which each one can bring their contribution. So this software delivery platform, if we're thinking about a multi-tenant environment, would allow us to have a simple app factory repository from where which can leverage three types of repositories as starters, or call them accelerators. One would be on the application side, one would be on the infrastructure side, and one on the environment side. We're not focusing on the infrastructure, where platform architects could provision files for creating clusters and configuring properly configuration and service accounts and whatever else is required. We're going to focus on the application. And we want to see how we can, let's say, if we put our architect hat, build a template which we would hand over to a developer or a developer team and allow them to build their own applications going forward. So let's think now. Let's see how we start this. When we Before we start talking about app acceleration, let's look at a template which we want to use. So the template we want to use, in our case, I pick an application, a Java template for a Spring Boot application, and the template would allow me to provision a number of files. And we mentioned all of those files before. The scaffold file, which would help us set up profiles, which we would use for development as well as for cloud deploy. The cloud build files as a template for building our application. On the deployment side, a simple declarative pipeline, which should leverage the three stages we wish to use. Testing, for example, staging and production. Different organizations might have more or only two stages. That very much depends on each organization. So, how do we start from this? Let's bring in our software delivery blueprint, and I'm not going to show you a UI. I want you to see what is happening behind the scenes. So we want to create an application. So this is a build pipeline which is invoked from a UI, and if we run this, it would take our template and build for us an application on which we can work. So let's call our application Modern App Dev Demo. The runtime would be Java for us, and it would match the template which we have. And where should we generate the code for that? Well, let's generate it in a subfolder under the same repository. Now, where should this repository, this starter repo, be created? So we will create this. I will put here my own GitHub repo and my user, and we want to generate the required artifacts for a Google Cloud project. So which project should we pick? This is a project which I have available, and this would allow us now to take that template and generate the application. Now, if we run this trigger, it would create the Git repo. It would provision Scaffold, Cloud Build, Cloud Deploy files, and a skeleton of our application, and provision it straight in Git. And we can continue working on it. Now, I ran this before because it would take us something around like 9 minutes to run. So let's move this aside and bring our other browser. So this is the repository which was generated, the one which we selected, Modern App Dev Demo, and It comes even with, because it's built on a template which we have, it comes also with a README file where you would have step-by-step instructions of how to clone it, how to set up the artifact registry for your images, how to do development, set up the database, create the build triggers, all of them very handy setup. The work is always on. The software delivery blueprint should help you start creating your development artifacts, and it's something which teams would take, architects would work on building the template specific for that particular organization. We can have recommendations and samples, but in the end, this is work which teams would be doing. So if we clone our repository, we'll use Visual Studio Code here with the Cloud Code plugin, which Google provides. We can see the same documentation available, and we want to run now a number of steps. So what should we be looking at? First, this is a Java 17 application. It uses Spring Boot. It's 268, the latest version, which matches also the native image at time when this was built a few days ago. And we have this entire application provision with all its dependencies, this Maven file. Now, we want to look at Scaffold because we're interested as developers in the inner loop, but Scaffold is part of Cloud Deploy. Cloud Deploy leverages it to provision our environments. So it creates a number of profiles. One is the development profile, which is our regular profile with an in-memory database. But we might also want to test against directly from our environment in Cloud SQL database. So we are shifting now slowly several of the aspects which we did not do in the past towards the developer. So we can now deploy into the cloud, test in the cloud with cloud technologies. Then it has the appropriate profiles for the test, staging, respectively production environment. So this is Scaffold. But Scaffold requires also some configuration. So for the different environments, we're using Customize, and we can see we're going to deploy in Kubernetes. We're going to see the different options. If we test with the cloud dev profile, we were going to use a Cloud SQL database. It's a Cloud SQL based on Postgres 13. And if we run just a plain development, we do not have to configure them. And we want to see a number of files indicating that we're running in the respective environment. So these files have been generated for us. It makes us, it gives us easy maintenance, and for us as developers, we can start working with them. Now we want to write our tests. Like for every application, we write our, if we are employing test-driven development, we write our tests, and we can evolve our tests. I've provisioned a few tests, and for this case, we want to use test containers. What do test containers entail? If we ran in the past our application with an H2 database, and we had H2 is a nice little tool, but many times there are discrepancies between H2 and different databases. So why shouldn't we run with a Postgres container, which should be the same Postgres as we would run into the cloud? So we write our tests, and I've added a few more. It sets up only the beginning, and I've added a few more tests. This is a quotes repository. We get some quotes from famous people. So we want to run our tests. As developers, now we shift this responsibility left, and as developers, we can run these tests from our machine. And if we look at it, we will see that it starts a Postgres 13 container. It will run the test, and then the container will be elegantly shut down. So We run our tests. We know that we have them. We can add tests as we go along. If we encounter different bugs as we go along, we can easily add our test and run this again. But we'd like to run test containers also part of the integration, and we will see how to do that. So we are, as developers, as an application, if we take our application, this is a Spring Boot application, we can easily run it. That's something which we are accustomed to. We can run it, we can debug it. This is something which we have been used to do. Now, how can we run this in the cloud? So if we look at the scaffold file, we want scaffold to help us build an image, and we want to, for this particular one, we generated with a template a zip file. We use zip for building the Docker file. We want to build the image, deploy it to Kubernetes in the same cluster which we have provisioned when we generated our sample, and we want to run it. So what do we expect now? So let's run our test on Kubernetes, and we're going to pick the development aspect, the development profile. So if we look at our development profile, we can see Kubernetes. It started an update, and it will build our application. What is actually happening? It is running our build, containerizing our build, and it will provision the image into artifact registry. Artifact registry scanning is enabled. So for us as developer, we have now the freedom of trying out different, if we'd like to use different images, or when we're going to look at build packs, use a build pack of our choice. But we do not need to get 100 approvals for that. In a true self-serve environment, we want to take our application, we want to try things out, but we also take it upon ourselves to scan the images quickly in the process. This build will take us probably around like 45 seconds. And now we're going to see this application being deployed to the cluster. It will also very conveniently port forward to a local host, and we see our application started. Now, before we test it, let's see if images are created. So there is an image created. We can see vulnerabilities. We can look at them. Well, this image has no critical vulnerabilities. It has a number of mediums or lows, and this might be an image which we might consider, and now we can engage the option. But we have the flexibility of running that. So we have shifted left testing. The next thing we have done is we have shifted left also not just testing with containers, but also quickly scanning the containers. And now we want to also run it in the cloud. So, well, let's see how we can run it. So we're going to send it a hello command, and it will say, well, this is your local environment, but this is an in-memory database. So this is fine. But we're thinking, well, can we actually run it with a cloud database? So why don't we stop this and pick a different profile where we want to run it with a Postgres database. It will build our image, but it will apply for us a different configuration. And that configuration will be, as we look into it, it will be the cloud dev configuration, which connects us to a database which we have set up before. As good practices, we set up proper secrets for our environment. So the application is up and running. It will port for the URL, and if we want to run our application again, it will tell us, well, now you have a different environment. So now we can run it. And as we're building applications, many times we create, unfortunately, memory leaks. So memory leaks can happen or errors can happen. Work for optimization as well as building reliability into our application is not starting when everything is deployed in a performance test or an user integration, user acceptance test environment. The responsibility falls on us developers, and we want to shift several of these aspects as early in the process because that increases confidence into how we build our application. So two things which we can do. We can run a number of load tests. So let's say I'm going to run a very simple load test for against our application. Do we really want to see the performance? Well, not as much, but what we want to see, and I've applied this with the customer, and they did not encounter any memory leaks anymore. We can run a slightly larger test. So let's say we take this quotes. This will give us a list of quotes which we have. But let's say we want to run a longer test, which developers can do easily. Well, there's a lunch break, there's the end of the day, there's time when you work, focus on other tasks. All these things, getting used to shifting these aspects left, have helped us build, have helped us build confidence in how we build our applications. The last thing which we are also interested in is how quickly do our applications start. So if we think about our applications, if we test them against maybe a database as we ran here against the cloud SQL database, will that give us a true measure of how the application will run in production? Not necessarily, but many times in an application, especially if we're used to building applications in the app server from the app server world, where we would load a number of items like as reference data, read-only data, that would increase our startup time. So we can observe quickly how long the application works. We cannot leave it for tuning after the application is built. Now the startup time is 10 seconds or a minute or two, because some things we can tune in the environment, but something we have to do in the application. So it's a combination which each one of folks in development or folks in operations would have to collaborate. So it's easier to build rather than to correct afterwards. But let's take an example. If we build our application and we said that we're interested in cloud economics, we're moving into a serverless environment. Startup is paramount. And even if it's not a serverless environment, when we want to scale up, the startup time of our application is paramount. So what can we do? In case of Java application, we can build native images. Is there a difference between them? Well, let's take our service and look if we deploy it in Cloud Run. It started in 7.8 seconds. This might or might not be acceptable. That very much depends. But if we build a native image, the same application built as a native image starts in zero point 0.3 of a second. So that's the aspect which we can recommend. We can test early. So we have done as we have shifted as much as we could left. Let's think now we want to build. So we want to have cloud build help us build our images. What do we want to do in cloud build? We want to build our application and we want it to fail fast in case our integration tests are failing. So here I'm using Maven Verify. It would run the integration test. If they fail, we stop the process. And we can run this very simple. As developers, we can run only the integration test. By this, again, we're building confidence. And then we can build our image. We can push the image to artifact registry and then build it. In this case, we deploy it to our Google Cloud, but we can as well deploy it to a pipeline which we have provisioned. So I'm showing you multiple environments, the build files, whether it's GK or whether it's serverless. In an application which you would be building in an enterprise, you would most likely be generating the application from one single environment, which is the environment of choice. But we mentioned that we can eliminate a lot of the friction between developers and um, ops folks. Well, what can we do? We can, very simple, build our image instead of leveraging a Docker file, as we did here, which took a Docker file and we use a Docker build. We can stop doing that, and we can build our image. And I'm building here a JVM image. We can build a native image as well. But cloud builds would allow us to build applications without the need of having Docker files. So it gives us now we test these applications with build packs up front, and then our folks by now know that these would run. Where is the advantage of maintaining them? If there is a CV, we don't have to update our Docker file. Ops folks can just leverage the notifications when a build pack changes and configure cloud build to automatically rebuild the images. So we set up triggers very easily on our repositories. I've set up the three, so we can have the cloud build, a cloud run, build and deployment, and one with build pack. So I'm not going to run them all. I ran them a few times. I just wanted to show you how they run. So we can see each step. One is to run integration. One is we build our image. Then we create an image with Docker. We push it to artifact registry. And in the end, we deploy it to our pipeline. If we choose to build it for cloud run, then the pipeline is we will run in the end a cloud run deployment. So the ability for us to configure this is very simple. Now, when we build templates, the platform architect does not want to have to remind maybe ops for, oh, should I enable binary authorization? What do I need to set up in the pipeline? Well, in the pipeline, they can simply simply enable binary authorization. Let's say as a minimum, we want to ensure that all our images are built by Cloud Build. And these can be provisioned straight up in the file. In binary authorization, we can see the policy and it's set up, well, allow only images that have been built by Cloud Build. And we know that we have built. If we're deploying on the GKE side, we have the pipeline, which was set up right away. The latest build built the image, deployed it to the test environment, and now all we have to do is promote images to the next test phase. So we looked at many aspects which we can now help build and which we can shift left as developers. And just to recap them, we can now run and debug in the cloud directly in Kubernetes, or we can run in Cloud Run. We can test with containers to have or to strive towards dev prod parity. So we shift that aspect left. We can scan containers early in the process, just as we were deploying our application. And then we can use load testing tools to gauge both the initial performance of our applications as well as eliminate memory leaks. So modern apps take these aspects now as table stakes. Yes, they're a change from how we did that before, but we did not have the abilities which we have in the cloud. And for all these aspects, the Google Cloud gives you simple, flexible tools, and we think in terms of outcomes. How easy is it for you to onboard an application? So you can see we can use an app accelerator and use templates. How easy is it to run? We can run Cloud Code, and Cloud Code runs on VS Code or IntelliJ. It's the environment of your choice. The next step would be how easy it is for us to build, to introspect, to log, to analyze our application at all time. We can always see what we are doing. We can see, well, binary authorization would have checked it. Of course, I left it as a dry run for now. We can see where our applications are. So it is this ease of use and making life for us, life as developers, easily. So before we go into Q&A, I want to thank you for the attention you gave me for these minutes, and I'd like to answer any questions which you might have. Okay, so the question, one question is this modern approach similar to DevOps or DevSecOps? Well, yes, but with the aspect of flexibility. In the end, when we build our applications, we focused on development, because we can see that there are major amounts of time which we can save and a lot of friction which we can eliminate. So in the end, organizations sometimes have their processes, or sometimes they want to build them. Some folks want to use GitOps or not. So the approach is bringing flexibility, and you can take any kind of variations which you would like to use. The software tree. Another question is, what is the software tree of this current project shown during the demonstration? If you can we scan the different types of the folders in the tree directory? Is there a precise structure suitable for Google infrastructure as well? So this, if we want to look at the structure of the project, again, so if we want to look at the structure of the project, let's move this up a bit. It's in the end, the structure of how you configure that is based on the template you would like to build. You might have your own tool. We just recommend this as a blueprint. What are our focuses as architects? How should we put these aspects? How should we give you the main aspects which you should consider as part of it? This is like a regular application. We just decided that we want to have our code into a separate folder. The structure which you would build, that is in the end up to you. This would be a standard, for example, here, Spring Boot project. The Docker file is a standard Docker file. Now, you can build a multi-layer Docker file or a custom one where you can put your own organization type of libraries. Then the files, when you would generate them, you can choose to have these into a separate folder. I showed you here, it will build you one. I showed you here multiple in order for you to see the simplicity of using it. Now, another question is, well, thank you that you liked it. Can we talk about blueprints, what they are, how to get them, and how to use them? Well, in our engagements with customers, we have noticed that multiple organizations, many organizations have their own type of app generators. If you would be working, for example, in an API first type of approach, I have worked with a couple of organizations which would take an open API specification, generate a project, generate the artifacts, and then build that. And whenever something would change within the interface, they would repeat the process. So again, we want to set up a blueprint rather than a product. As it would come along, that's a different thing. This is the first time you see it, but we want to bring the aspects, the concept of segregation of responsibilities, what each one of us does, having YAML files, which would help us. We're not fixated on the idea of YAML, but it's the idea of having declarative deployments, because we can put them in Git, we can version them, we can govern them, we can ensure that they're consistent, and we can as well review them. So another question is, it would be nice to see this in this diagram, an alternative to cloud build, such as Terraform Enterprise. Sure, you can use if you would like to do that. What I'd like to do, and many customers are asking me, show us a simple process, show us a step-by-step process. I have 2 children. My children like Legos, so many customers use the analogy of Lego blocks. Can we use the Lego blocks and build them? Yes, you can use that. For example, one of the other workshops, which follows this, around focus more on optimization, now that we have the concept of modern app development put forward. And one of our other workshops has, for example, a Terraform file, which will set up for you, say, Cloud SQL, set up provision any kind of, for example, service account, set up scripts, and whatever you would require. So that in the end, is in the end something of your choice. The idea is, I like flexibility, and as much as I'm not into politics, I'd like to quote the politician Rumsfeld, who was talking about the known knowns, known unknowns, and the unknown unknowns. What are we looking at? We are looking at flexibility so that we be prepared for the unknown unknowns. Teams will build different applications, and they need to have full flexibility. But what they need is understanding where they can save time, where can they focus their time on their business value, because this is where they're good at, and they don't want to be mired into long processes of, oh, how should we do this, how should we do that. I've talked to a customer who moved from Docker files to build packs because they had hundreds of pipelines. So suddenly they could rationalize that. What did it save them? Maintenance effort. How quickly you respond to CVs. So that's what we want to be prepared of. So to set up a project, what are the norms and standards? So I ran this within my own account, within the Google Cloud. So if we, the question would be, well, how would we set up the project via the Google web browser? So for example, you noticed I was logged into a project. That project would be set up by the architects, and I put here software and infrastructure and architects, who would have the view of the templates they'd like to build, and this is an environment which they would run. Now, teams would have access within an organization for it, and that very much depends how you structure the organization. You would provision that in one of the projects, or let's say you have it in a folder, and you provision that and run it for the project of your choice. I ran this here. as this is running in someone else's project, and the organization for my own internal project is a little bit different than maybe some other organization would set them up. Um, Another question would be uh, around how to set up a health check for an application in serverless environment if we talk about production readiness. So I can show you that. So if we look at an application, and I have several applications. This is an application which is a BFF, which fronts the same quotes application. So this application, if we're looking at it, this being a Spring Boot application, it leverages Spring Boot actuators. And if I'm looking into configuration, because I can, even for Cloud Run, I can deploy via declarative, use declarative deployment. I'm going to set up configuration, but I can set up both, let me increase the font a bit. I can set up a liveness probe and I can set up a startup probe. What would I have to do here? I have to provision a custom health endpoint and startup endpoint for my particular application. For example, this BFF reads some read-only data, and I use it for an optimization workshop. But yes, you can set this set this up for that. In setting up health check and liveness and startup probes, you do them in Kubernetes. You do them also in Cloud Run, and you can, if you would provision that via template, you can provision that in a template. So it's just think always about the idea of consistency, of easy onboarding. If I can take a project and I can easily generate a skeleton, and the Maven file is created by best practices, by minimizing the number of dependencies I have, or avoiding class indexing, or a number of things. Everything which I can do that. I can build cloud build files. So in the end, it's the blueprint of how you would use that. Okay, so with no further questions, I'd like to uh, uh, thank you for attending the session, and I hope I leave you with some concepts. When we build apps today, it's not 2022. It's we build apps for the cloud. We build them in different premises. We build microservices. We decompose monoliths. We build brand new applications. We want to think about what we can do to make our life as developer easier, but also what we can do as architects, and how what we can do as operators. So without without further ado, I want to thank you for participating, and I'd like you to ask you to also visit this link. It's cloudonair.withgoogle.com /cloud innovators, and to learn about new and upcoming live events. There will be some very interesting ones following up this particular session on serverless, on development, on other aspects, and we hope that we slowly build this kind of material, which should give you practical, direct hints which you can apply in your day-to-day work. So thank you again.